Hello to all of you. This is Dr. Dhaval Maheta, and today we are going to discuss feature selection of the data. Machine learning models follow a simple rule. Whatever goes in comes out. If we put garbage into our model, we can expect the output to be the garbage too. In this case, garbage refers to the noise in our data. To train a model, we collect enormous quantities of data to help the machine learning better. Usually, a good portion of the data collected is noise. While some of the columns of our data set might not contribute significantly to the performance of our model. Further, having a lot of data can slow down the training process and cause the model to be slower. The model may also learn from this irrelevant data and can be inaccurate. Feature selection is what separates good model from the worst model. So the feature selection is a process where you automatically select those features in your data that contributes most to the prediction variable or output in which you are interested. Having irrelevant features in your data can decrease the accuracy of many models, especially linear algorithms like linear and logistic regressions. The benefits of performing feature selections are it reduces the overfitting. Less redundant data means less opportunity to make decisions based on noise. Second, it improves the accuracy. Less misleading data means modeling accuracy improves. 3. Reduces training time. Less data means the algorithms trains faster. The first is univariate test to detect the best variables. Statistical test can be used to select those features that have the strongest relationship with the output variable. The scikitlearn library provides a select k-based class that can be used with a suite of different statistical tests to select a specific number of features. The example below, which we have considered here, is of PEMA Indian diabetes. This dataset is readily available on Kaggle website. Now, how we can do this? Let's say in Python. From pandas import read underscore CSV. From NumPy import set print options. From sklearn.feature underscore selection import select k best. From sklearn.feature underscore selection import chi-square. Basically, it is 2 is chi-square. Then we will have to load the data. So file name is equal to, we will specify the path where our database is located. So the data set should be kept in inverted commas. Names is equal to, we will specify the variable names. So 0, 1, 2, 3, 4, 5, 6, 7, 8. It starts with 0. Data frame is equal to read underscore CSV file name. This is a file name which we are specifying. Names is equal to names. Array is equal to data frame dot values. Now we will select X is equal to array. Color means applicable to all the rows. We are selecting 0 to 8. X, Y is equal to array, applicable to all rows and the 8th column. Feature selection. Test is equal to select k based score underscore function chi-square based on chi-square. K is equal to 4. Fit is equal to test dot fit X and Y. Summarize the scores. Set underscore print options precision level should be 3. It means that generate the output in 3 decimal. Print fit dot scores underscore. Features is equal to fit dot transform X. Now the next command is print features 0 is to 5. It means generate the first 5 rows applicable for all the columns. Now we will have to see the maximum chi-square value. You can see 1, 2, 3 and 4. So this is related to plasma, 1411, skin, test and mass. So these are the best features for creating the model. Next we will see the recursive feature elimination. The recursive feature elimination or RFE works by recursively removing attributes and building a model on those attributes that remain. It uses the model accuracy to identify which attributes contribute the most to predicting the target attribute. Now let us see how we can do this in Python. So for this, from pandas import read underscore CSV. From sklearn.feature underscore selection import RFV. From sklearn.linear underscore model import logistic regression. We will have to specify the file name. The path is to be specified, names, the variable names. Data frame is equal to read underscore CSV, file name, comma, names is equal to names. Array is equal to data frame dot values. Again, X and Y specified as we have seen previously. This time I'll be using model is equal to logistic regression solver equal to LBFGS. LBFGS stands for Limited Memory Broyden Fletcher Goldfarb Sano. Basically, it's a solver. RFA is equal to RFE model, that is this model which we are talking about. Fit is equal to RFE dot fit X and Y. Print into inverted commas num features colon %d %fit dot n underscore features. So it will generate this value num features. Print selected features %s, so %fit dot support underscore, so it will generate this part. Print feature ranking colon %s %fit dot ranking underscore, so it will generate this values. So wherever we are getting true, it means that these features are good features. So preg, plasma, then paddy and age. We can consider this feature or we can consider this variable for constructing the model. We have also got the ranking 1, 1, 1, 1, 2. So you can also select the variables based on the ranking. So first are preg, plasma, paddy, age and class can be selected for creating the model. Next is the feature extraction, which is done with the help of principal component analysis. Principal component analysis uses linear algebra to transform the dataset into the compressed form. Generally, this is called a data reduction technique. A property of PCA is that you can choose a number of dimensions or principal components in the transformed result. Let us see how we can do this in Python. So for this, import numpy from pandas import read underscore CSV. From sklearn.decomposition import PCA. We'll have to specify the file name as we have done it previously. We'll have to give the names that are the variable names. Data frame is equal to read underscore CSV. We'll have to specify the file name, the names of the variables. Array is equal to data frame dot values. X is equal to array, that is into square bracket colon applicable to all rows, comma. We have to select the columns from here. Y is equal to array applicable to all rows, and we'll have to select the target variable, which is our class. Feature extraction is equal to PCA is equal to PCA n underscore components is equal to 3. We want the output. We want to extract. We want to compress the data into 3 components. Fit is equal to PCA dot fit X. Then we will summarize. Print is equal to print round bracket into double inverted explain variance. Whatever we write in the double inverted commas, it will be generated in the output. %fit dot explain underscore variance underscore ratio underscore. So we got the values. Print fit dot components underscore. Now here the explanation here is little bit difficult. Why? Because we will consider the first axis, which is able to explain 88.9% variance, and therefore we will consider all the features which are there in this first axis or the first dimension. So the interpretation is little bit difficult. The next method is extra tree classifier. Back decision trees like random forest and extra trees can be used to estimate the importance of the feature. Now, how we can do this? Let's see in the Python. So from pandas import read underscore CSV. From sklearn.ensemble import extra tree classifier. we'll have to specify the file name and we'll have to give the path where the data set is located. Names, we'll have to specify the variable names. Data frame is equal to read underscore CSV file name, comma, names is equal to names. Then we will have to make the array. Array is equal to data frame dot values. X is equal to array, colon, comma, 0 is 0 is to 8. Y is equal to array, colon, comma, 8. This Y we are specifying for the target variable. Models is equal to extra trees classifier, round bracket, model dot fit xy, print model dot feature underscore importances underscore. So all those variables or features which have got the highest value are considered to be the good features. So we can see 0.233 is the highest value here, 0.107 is the highest value here, and other values are 0.147 and 0.14. These values are for Prague, Plus, Paddy, and Class. You can also take Edge. You can also run multiple algorithms to extract the best features. All these commands are available in the book written by Jason Brownlee. The title of the book is Machine Learning Mastery with the Python. For more videos on machine learning using Python, kindly subscribe to my channel. You can press the like button. You can see my playlist in which I have already uploaded many videos related to machine learning using Python. Please don't forget to press the like button. You can also follow me on LinkedIn and Twitter.